Welcome back. Consider the problem. Solve z square minus 2yz minus y square into p plus xy plus zx into q is equal to xy minus zx. So, if in this question you can apply any method. In the question it is not given that you have to apply the method of multipliers, or you have to question it is not given that you have to apply the method of multipliers or method of grouping. So you have to choose the possible method which is applicable to each question. So you will get that idea by doing only some problems by yourself. Now let us see the solution. Now the given equation is of the form PP plus QQ is equal to R. Now comparing with that general formula, we can write P is equal to z square minus 2yz minus y square, Q is equal to xy plus zx, R is equal to xy minus zx. Now in this case, the first step is write down the subsidiary equations, that is dx by p is equal to dy by q is equal to dz by r. Now look at the equation and check whether it is possible to apply grouping here. No, when we consider the first two equations, all the variables are present. Z is also present and we are not able to eliminate Z from that relation. So we cannot consider the ratios 1 and 2 for grouping. Also when we consider the second and third fractions, there is also the variable Z. We cannot cancel that Z. So we cannot choose that ratios also. When we consider first and last ratio also, all the variables are present and the variable y cannot be cancelled from first and third ratios. Now let's see how if it is possible to find multipliers for these relations. That means we have to find L, M and N. That may be constants or functions of x, y, z, such that L into this expression plus M into this expression plus N into this expression is equal to 0. Now when we are choosing the multipliers, you have to remember one thing, that we are multiplying multiplying that terms with the denominator. At the same time also we are multiplying the numerator also and numerator also. So you get L dx M dy plus N dz, and the corresponding operations are done, L dx plus M dy plus N dz. So and next step is you have to integrate that term. So you have to choose multipliers in such a way that L dx plus M dy plus N dz should be integrable also. If it is possible to integrate that term, then only you can choose the multipliers in that way. Now take x, y, z as multipliers. We get each fraction is equal to x dx plus y dy plus z dz divided by x into p plus y into q plus z into r. So the denominator get cancelled. So you have to choose the multipliers such that the denominator get cancelled. So that can be done only using some trial and error method. You have to choose some functions and find out these product and adding that terms you have to get 0. That can be done only using some trial and method. That is also possible if you done some problems by yourself. Now from this expression we can write x dx plus y dy plus z dz is equal to 0. So this is an integrable function. So you can integrate, get x square by 2 plus y square by 2 plus z square by 2 is equal to c1. Take c1 2 as common and cross multiplying it, we get x square plus y square plus z square is equal to 2c1. So 2c1 is a constant, I call it as some a. So we get u is equal to x square plus y square plus z square. We take it as equation number 1. Now when here we are applying another trick also. We are taking the second and third fraction. So you get dy divided by xy plus zx is equal to dz divided by xy minus zx. So that dy divided by here x is common, so that x get cancelled. So we get dy divided by y plus z is equal to dz divided by y minus z. So here we can choose the second and third fractions. Previous I told that it is not possible, but here it is possible. Here we can cancel x also. So when cross multiply it, we get y dy minus z dy is equal to y dz plus z dz. So rearranging, we can write y dy minus z dy minus y dz minus z dz is equal to 0. Again rearranging, we can write y dy minus of z dy plus y dz minus z dz is equal to 0. Now, when we look at this expression, y dy minus of z dy plus y dz minus z dz is equal to 0, you can integrate the term y dy and z dz. But what about z dy plus y dz? So, that can be written as d of zy. You have already studied the total differential. Using the property, we can write y dy minus d of zy minus z dz. Now, if we are comparing this with the product rule, we can write first function into z into dy, first function into derivative of z. So, z into dy plus second function into y into derivative first, y into dz. In that way also you can remember this one. Actually, we are applying the concept of total differential. So, you get y dy minus d of zy minus z dz is equal to 0. Now, integrating. Now we are integrating, we get integral of y dy is y square by 2. Now, what about integral of d of zy? Now, we know that integral dx is equal to x, integral dy is equal to y, integral dt is equal to t. Then what is integral d of zy? It is same as zy. So, you get y square by 2 minus zy minus integral of z is z square by 2 is equal to c2. So, you can we take here 2 as LCM and cross multiplying it, we get y square minus 2zy minus z square is equal to 2c2. So, you get v is equal to y square minus 2zy minus z square. Let us take it as equation number 2. So, from 1 and 2, we get the complete solution as phi of u be equal to 0. That is phi of x square plus y square plus z square comma y square minus 2zy minus z square is equal to 0. So, this is the complete solution of our given equation. Thank you.